Welcome to my video on the synapsis of chromosomes and meiosis through the story of the colorful jellyfish. Today we're meeting our two jellyfish friends. They each have a different color pattern on their tentacles based upon the order to the right. Also, on each side of their bodies they have different amounts of dots based upon the location of their heads. So one day jellyfish decide they want to share and swap their colorful dots. They specifically want to between their turquoise and hot pink colors. They begin to trade by lining their heads up and looping their four tentacles around each other, making sure to cross their tentacles between the turquoise and hot pink colored dots. They continue to loop and unwind themselves, noticing they have traded and even copied multiple of each other's colored dots on their tentacles. When they get unwound, our jellyfish knows they now have a new color patterns. Their share and swap was successful. Their new order of color is written to the right. Our jellyfish also knows they can split their tentacles and share even more. After they split, we have four jellyfish with different color patterns. All of them are happy and want to share more. However, only jellyfish with one of each color can share more. If you look at the patterns, jellyfish 1 kept its original order and has one of each color, possessing no duplication or deletions of dots. It is good to share. However, if we look at jellyfish 2 and 3s, we see that they have duplications and deletions of certain colors on their tentacles, so they can't share anymore. Lastly, jellyfish 4's pattern is a new combination of dots, but there is no duplications or deletions, so it can share like one. What occurred between jellyfish and their colorful dots also happens with our chromosomes in real life. Instead of having dots, we have orders of nucleotides in our chromosomes. If this was an individual, they would have two heterozygous chromosomes that possess a different order and that have different placement of their centromeres, which is equivalent to the heads earlier. Because of these attributes, this crossover between J and K in synapsis and meiosis is a pair-centric inversion. The chromosomes will use an inversion loop that includes the centromeres. As seen in the picture, once the crossover happens, new orders are formed and separate 2 times to eventually get 4 gametes in the end. We can check out the orders for deletion and duplication that can make the gametes non-viable. Pericentric inversion increases an individual's fitness. Despite having 50% non-viable, this type of cross promotes more diverse traits that can lead to speciation and that help with the adaptability of gametes that make them successful for reproduction. Next, we get to meet two more of our jellyfish friends. They each have their own color patterns on their tentacles based upon the order written to the right, which are identical to each other. Their heads are in the same location and have the same amount of dots on each side like the other one does. These jellyfish were inspired by the others to share and swap between their turquoise and hot pink dots. So they meet and begin to trade. Their heads are already lined up and they only have to cross over one of each of their tentacles between the turquoise and hot pink dots. They do not need to continue to loop like our jellyfish did earlier. With one that crosses the tentacles and simply unwinding, they're done with their trade. Now done sharing and swapping, we can admire their patterns of colorful dots. However, we see that their order of patterns is the same. Even when they decide that they want to share some more and split, all 4 of the jellyfish still possess the same colored dot pattern. None of their dots were lost or duplicated, and all of their orders are viable. So even without a new pattern, they still are happy and healthy to share again one day. As before, we learn more about the synapsis of chromosomes and meiosis through our jellyfish. In real life, if the individual possesses 2 identical chromosomes, they will do a simple cross and still have 4 identical viable gamete combinations. They will have a good fitness and continue to reproduce in a large population. However, unlike heterozygous pericentric inversion, the divergence and speciation will not occur. So if something happens to our population, they are less genetically adaptable and could die off, lowering their fitness. Thanks for watching.